look at some of the problems from the homeworks. And so the first one was we had a function x e to the power 2x, and they asked us to find a power series, the Taylor series for this thing. All right, so what we need to do is, first of all, we go to ex itself, so that's step 1, if you want. What's the power series of ex? So I'm going to write it again using my parentheses, and then I plug in thing in the parentheses. Okay, so it is 1 plus x over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial plus etc. And the use of convergence is infinite, so we don't really have to worry about it. Once you have that, you don't have to worry. So next, I'm going to plug in what I'm going to plug in. Well, this time I have to plug in 2x, okay, because that's what I want to get here. So if I do this, my series is 1 plus 2x plus, okay, right, so let me write it, sorry, that was all point, right? 2x here, 2x, 2x, so what does this give me? 2x squared, that is 4x squared over 2 factorial. We can simplify this, so let's write 2 here, plus 8x cubed over 6 plus etc. Right, that's step 1. Well, it's kind of, and step 2, it's very easy now because x itself is just a single power. If this would be another power series, we would have to find that one. We did this in the session last time. Okay, so now we have to e to x. That means x times this series that we just had written down. I'm going to simplify this here as 2x squared. We can perhaps also, it's not necessary, but okay, I'm going to do it 4x cubed over 3 plus etc. And now we multiply this out, that is x plus 2x squared plus 2x cubed plus 4x to the 4th over 3 plus dot dot dot. Now in the book, if you look at the answer of the back of the book, perhaps, oh no, this one won't have any, they would like to do this with the summation sign. But I told you, for me, it's okay to do it with the dot dot dot, and therefore write down the first, let's agree to at least the first 4 non-zero terms. Let's make that our standard, and then if I say something else, then you do it something else. But if I don't say anything, at least 4 non-zero terms. That is not the same as up to degree 4 or degree 3 for that matter, right? Because sometimes you have skips, especially with sines and cosines, remember. Okay, so that was number 202. That was rather easy. In some sense, the homework problems were slightly too easy. So I'm going to ask you a little bit more harder problems, but I'll do a review for that again. And then the other one was 221, and that was, okay. Perhaps this, also this one is actually, so number 221, you said at least the first 3 non-zero terms. Let's stick to the first 4 non-zero terms. Okay. It might be slightly more difficult in this kind of problem. Okay, so we have ex cosine x. Now we have a series for both of them right away. If there would be something else as instead of x, then we would have to first plug in and then multiply, right? But that's what I'm saying. I would have done a slightly more complicated question. Okay, so the series for ex is 1 plus x squared over 2 plus x cubed over 3 factorial, which is 6 plus, again, and the cosine, remember, that's the even powers, right? Yes, so it's 1 minus x squared over 2 plus x to the 4th over 4 factorial, which is 24, minus x to the 6th over 6 factorial, which is 120. No, 720, sorry. Yeah, these numbers get big, right? We can write 6 factorial plus dot dot dot. Okay, so now we have to multiply this out, and so in other words, you can do it whatever way you want, you know, but I find it very easy to just, sorry, no, I didn't want to drive this time. Look at the various powers here. 1x, x squared, x cubed, x4, I don't know exactly how far I have to go because we agreed, it said the first four, the book, the homework asks 3, but I'm going to do 4 non-zero terms. Now you say, how do I figure it out? Well, that's what you do, right? You keep finding the coefficients here and until you have 4 non-zero coefficients, and then you can stop. That's it. Okay, so let's look. And you see here, because both actually start with a 1, we have quickly a lot of terms. Okay, so let's start with 1 itself, the constant. Well, yes, because if I multiply this with that, I get a 1. Okay, so what about x? I'll do different colors, x. So I have this one, but I cannot combine it anything because it's all even powers here. So that's not going to give me anything, but this x combines with this one to give me an x. So that gives me coefficient 1 as well. Okay. What about x squared? This one combines with this x squared and I get minus a half, right? Because the coefficient here is 1 at the left and in the right it is minus a half. I have to multiply the coefficients. Please do not add them here. Just multiplying. Once you've made the table, then we're going to add. Okay, is there anything else I can do with this x? No, it's something missing, but be careful. This x squared I can combine with this. Okay, and so, well, I shouldn't have circled it. Let me underline it. Can I combine it with this here? So I get another half. So half here. Now we're going to add these things up. Yeah. So this, let's do this, add this up, right? So this actually all pluses here. So this actually is 0. Can happen, right? So okay, so this is gonna have to look further for more. We did already orange, red. That's the x cube. This one, no, that's not gonna combine with anything. But this x combines with this. Oh, sorry, you should write it here. So that gives me minus a half here. Is there anything else I can do? This one, nope. But yes, this one combines with this one, and so I have a 1/6 plus 1/6. So that is minus 3/6 plus 1/6 is minus 2/6, which is minus 1/3. Okay, so we have already 3 non-zero ones, so I need one more. Hopefully x to the 4th will be that. So let's see, can I combine this 1 with the x to the 4th? Yes, that gives me 1/24. This x, nope, because it's all even powers here, but this x squared combines with this one. Now we have a half there and a minus a half. If I multiply, I get minus 1/4. Okay, and then x to the 4th I'm doing x cubed. Nope, I cannot do anything here. Now, at this point we should realize, well, x to the 4th, there is actually a term in my dot 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 here that would contribute and I didn't write it down. This can happen. And you have to be very careful that you don't forget anything. So sometimes it's safer to do a little bit more terms here. Well, let me do this in black. So next one, x to the 4th over 24, 4 factorial, right? So this one now can, I was doing blue, right? So this x to the 4th combines with this one and gives me another, it's a plus, right? Plus 1 over 24. So I get here 1 minus 6 plus 1, 24. So I put everything on common denominator 24. That's where the minus 6 comes from. So I get minus 4 over 24. That is actually minus 1/6. Now I have 4 non-zero coefficients, so I can write down the power series. Remember, these numbers that I just found are the coefficients of the powers that I have here. So I have a 1 plus a next one, the yellow one gives me an x, the green one gives me a 0, then the red one gives me 1 minus 1/3 x cubed, and the blue one gives me minus 1/6 x to the 4th, and then dot dot dot. And that's how you solve this. Okay? Alright, that was not so difficult, right? But as I said, I'm going to do slightly more complicated. For instance, instead of ex cosine x, I would do, for instance, ex squared times cosine x third, or something like that. So we have to do some extra step. But the principle is really the same.